Hi to everyone. Myself Prabhdeep Singh, Assistant Professor in Computer Science and Engineering Department of School of Engineering. Today I am going to discuss the topic Introduction and Basic Concept regarding Optimization Technique. The objective of this teaching is to understand the purpose and the origin of optimization strategies, get the general picture of how optimization methods are applied in engineering. By introducing optimization, the act of achieving the best possible result under the given condition. Design, construction and maintenance of engineering system require decision making at both the management and technological level. For that we need the optimization solution. In order to get the optimization solution, either it should be a maximum or minimum should follow the constraint as well as the restrictions. By achieving the optimization technique, the goal for such judgment include to minimize the effort required and to maximize the desired benefit. Seeing this graph, we can say that we are getting a minimum of fx and maximum of minus fx. It can be seen from the figure that if a point x correspond to the minimum value of function fx, the same point also correspond to the maximum value of the negative of function minus fx. Thus, without loss of generality, optimization can be interpreted as minimization, as the maximum of a function can be determined by seeking the minimum of its negative. So by all this we can say the definition of optimization means it is defined as the process of determining the condition that result in the least or the greatest value of a function, where the function reflects the effort required or the intended benefit. Now there is no single method available for solving all optimization problem efficiently. As a result, several optimization approaches have been created to address various sort of optimization problems. The optimum searching method, also known as mathematical programming approaches, are typically investigated as part of operation research. Operation research is a discipline of mathematics concerned with applying scientific ideas and procedures to decision making problem and determining the best optimal solution. When we are discussing about operation research, there are various methods. These methods are categorized as mathematical programming or optimization technique. Second category is stochastic process technique, and third category is statistical method. Under mathematical programming, we are studying about calculus method, calculus of variations, non-linear programming, geometric programming, quadratic programming, linear programming, dynamic programming, integer programming. And in the stochastic process technique, where the uncertainty of constraints are happened, these methods and techniques we are going to study, like statistical decision theory, Markov processes, queuing theory, renewal theory, simulation methods, reliability theory. In statistical method, under statistical method, we are going to study regression analysis, cluster analysis, pattern recognition, design of experiment, discriminant analysis, and factor analysis. Other two categories are also defined under operation research in the mathematical programming, or you can say optimization technique, that is stochastic programming, separable programming, multi-objective programming, where we have multiple objectives which contradict each other, network methods, game theory. Last, we are having modern, or you can say non-traditional optimization technique. Under this, we are going to study all modern optimization algorithms such that genetic algorithm, simulated annealing, ant colony optimization, particle swarm optimization, neural network, and fuzzy optimization. The history of optimization development are: optimization methods have existed since the day of Newton, Lagrange, and Koch. Newton and Leibniz's contribution to calculus enables the development of differential calculus optimization approaches. Bernoulli, Euler, Lagrange, and Weierstrass created the foundation for the calculus of variation, which deal with function minimization. The approach of optimization for a constraint problem, which involved the inclusion of unknown multiples, was named after its originator, Lagrange. Koch was the first to apply the steepest descent approach to solving the unconstrained optimization problem. High-speed digital computers enable the implementation of sophisticated optimization algorithm and encouraged continued research into innovative technologies. There has been a significant amount of literature on optimization technique, leading to the development of new field of optimization theory. Milestone regarding optimization technique is Dantzig developed the simplex approach in 1947 for linear programming problems. Bellman's 1957 formulation of the optimality principle for dynamic programming issues. Cohn and Tucker in 1951 work on the necessary and the sufficient criteria for optimal problem solving set the groundwork for subsequent non-linear programming research. Dantzig and Rosen contributed to non-linear programming in the early year of the 1960s. Carroll, Paco, McCormick's work allowed the solution of many challenging problems using well-known unconstrained optimization technique. Duffin, Jenner, and Peterson first created the geometric programming in the 1960s. Gomre produced groundbreaking work in integer programming. The majority of real-world applications fall within this group of challenges. Dantzig, Carnas, and the Cooper created stochastic programming approach. The desire to optimize more than one objective or aim while remaining within physical constraint prompted the creation of multi-objective programming methodologies such as goal programming. Von Neumann established game theory in 1928 and has since utilized it to tackle mathematical, economic, and military challenges as well as engineering design problems. Simulated annealing, evaluatory algorithm, and neural network approaches are the example of innovative mathematical programming technique that have emerged in the recent decade. So optimization is its broadest sense can be applied to solve any engineering problem. Some typical application from the different engineering disciplines indicate the wide scope of the subject: design of aircraft and aerospace structure for minimum weight, finding the optimal trajectories of a space vehicle, design of a civil engineering structure such as frame, foundation, bridge, tower, chimney and dams for minimum cost, minimum weight design of a structure for earthquake, wind and other type of random loading, design of water resource system for maximum benefit, optimal plastic design of a structure, optimum design of linkage cams, gears, machine tools and other mechanical components, selection of machining conditions in metal cutting process for minimum production cost, design of material handling equipment such as conveyors, trucks and cranes for minimum cost, design of pump, turbine and heat transfer equipment for maximum efficiency. Then optimum design of electrical machinery such as motor, generator and transformer, optimum design of electrical network, shortest routes taken by the salesperson visiting various cities during one tour. Other optimization techniques in the engineering field is optimal production planning, controlling and scheduling, analysis of statistical data and building empirical model from experimental design to obtain the most accurate representations of the physical phenomenon. Optimum design of chemical processing equipment, design of optimum pipeline network for process industry, selection of a site for an industry and inventory control, etc. Then allocation of resources or services among several activities to maximize the benefit. Then controlling the waiting and the idle time and queuing in the production lines to reduce the cost. Planning the best strategies to obtain the maximum profit in the presence of